Hey, hello everyone. Yeah, I was already introduced, so let's get into it. It's a lightning talk. We gotta move fast. React compiler deep-ish. Dive into performance. Quick reintroduction. I'm Mykyta. You can also call me Nick. I'm engineering manager at LeanDNA, React enthusiast. One of my longest-standing and favorite technologies to use when building web applications. So let's jump straight into it. Why compiler is needed in the first place? And the short answer is re-renders. We are battling re-renders in React. We are trying to make sure that we are not re-rendering and running our CPU just for the sake of running, which brings us to the thing where we are stuck with useMemo and useCallbacks. And this is a live picture of me trying to debug why the hell our TBT or ENP jumped like 3 times when someone forgot to memoize one of the objects when they pass in the longest chain of useMemo and useCallbacks. You all probably experience those long accordions of useMemo and useCallbacks in your React DevTools. So what is compiler, right? Just to put it in the simplest way possible, compiler just takes care of your effort to memoize your application. So imagine on the left you have your default component, and to the right you have all of the things it needs memoized. So useMemo, useCallback. But a big asterisk to that is compiler does not include useMemo and useCallback hooks in your application. It does internal memoization, and we'll talk about it a bit further down the line, right? When we'll talk about what compiler does. So main thing I will tell a bit of an edgy point, but yes, it will allow you to throw useMemo and useCallback to the dumpster. You can stop using them, you can stop thinking about them for the 99% of the time, and then 1% where you want to squeeze the best performance out of your app. This is where you'll need to dumpster dive back and resurrect this useMemo and useCallback usage. But let's take a simple component in mind. We have a component that has a variable introduced right into the component body, which is environment production. So the difference between compiler and Babel transpiler would be that to the left, you see that it keeps the variable there. So it introduces the variable and then it uses the variable when it tries to return the child component. Compiler, on the other hand, while doing a lot of other magic, and as you can see, it does not keep the track of the variable. So this is the simplest example to explain that compiler is much more invasive when it comes to transforming your React code into a source code, but it's a good thing. Do not worry about it. People and the team that was developing compiler, they definitely know their stuff. So it also introduces a bunch of improvements in terms of building opportunities and reducing building time, which we'll also talk about later. So just a couple of examples. What compiler will do for you is, for example, we have this onChange function, which in default circumstances we would wrap into useCallback. But in the source code, you see that onChange function is now referenced as temporary, and temporary is now introduced outside of the component. So now every time we call a component function, our temporary function is a static reference, which we can use. So it frankly did a memoizing for us instead of us even thinking about it. Another example is a good one where it also knows how to use dependencies. So onChange is returning a data, and data is an object defined, and all of that happens in the body of the component, which means that usually we would do a useCallback that would have a dependency. But in this case, I'll just highlight a simplest thing. It defines a variable, it puts it as data, and then it knows how to use it in data. So the T0 and T1 are 2 parts of it. So data is our T0 and onChange is our T1. And as you can see, it keeps the consistent reference and it knows to reassign it when it's changed. This is a little bit bigger example of how it does not use useMemo and useCallback at all in its code base. As you can see at the top left, caller is a memoized variable, and to the right in the compiler source code, it doesn't have any useMemo call. It just knows what to do. It keeps track of it itself. And this is also another great thing about compiler. It will actively remove overheads for your useMemo and useCallbacks. It will handle it themselves if it can. It's not invasive. If it can't, it will just skip your component, so you don't have to worry about breaking your app. This is just a highlight. If you want to see how the compiler works, folks at Meta did a great playground where they show each step that compiler takes, and one of the steps is drop manual memoize step. So compiler will actively try to help you get rid of memoization in your build. Okay, so let's take an example of the simplest component out there. We have a button, we have a state, we have our event handler, and we have our very slow component. So as you can see, the result is very slow component is memoized, and compiler is showing you with the sparkle that, hey, I did the job for you. Don't worry, I got you. Okay, so the graphs part. The graphs part is how we will be measuring what compiler did. Did it help us? Did it hurt us? What are the edge cases? Let's talk about the basic rules. For UI performance, I went as simple as Lighthouse, average of 5 in development mode, not production mode. Why? Just to show you the difference. So the deltas in percentages will be less in build mode. So development mode, just to exaggerate the difference. And it's mobile mode, slower CPU, again, just to make sure that we are not hitting like as smallest changes, we're hitting substantial changes. Bundling, opted out to use Webpack. I know, Vite, RSPack, there are a lot of new shiny things, but Webpack is old, true, tried and trusted, average of 3 and fresh versus cached. And for measurements on the UI performance, we'll be using largest content point, total blocking time, interaction to next paint, and total blocking time. Those are on interactions, and on interactions, that's the area you might be interested the most, because if compiler memoizes everything for you, it should help with that drastically, which we'll see most of the time is the case. So Exhibit A, 4,500 lines of code. This is a small YouTube clone app. As you can see, not drastic difference in terms of largest content paint, just because there is a lot of media, a lot of thumbnails to load. So not getting huge kick out of it. But when we hit the total blocking time on our load, we see that compiler hits bigger numbers, 300 milliseconds versus around 230 milliseconds, which is a sign that it tasks CPU and puts stuff into memoization, so it needs a little bit more time when you just hit the page. But the weirdest picture that you'll see in this case is our interaction to next paint gets worse with compiler. And for total blocking time, the picture is the same. Why is that? This is a good example of do not apply every technology as soon as you see it, because in this case, YouTube clone app, every time you click a button, you change the page. So you frankly reload almost the whole app. And again, you're getting a hit of a completely new subset of components every time you switch the page. Meaning that React now has to memorize everything yet again and yet again, which will actively hurt your performance. Not drastically, as you can see, it's fine, but the difference is there if you are the performance geek. Keep that in mind. And in build time, we have a little bit of uptick in the build time, around 10%, pretty negligible in my opinion. Okay, so Exhibit B is 3,000 lines of code. This is an advanced to-do app. Think about it like a mix of to-do app with Trello board. As you can see, largest content paint is almost the same, less media to load. So we'll focus on total blocking time. Again, on the initial load, React sweats and tries to memorize everything you do, but the hit is not very drastic. But this is where we struck gold. As you can see, interactions to Next Paint is substantially lower, almost 2 times lower, which is a very, very, very great thing to have. Everything we do, every card we move, every button we click just goes faster, and total blocking time stays the same, meaning that we are just gaining performance out of thin air just by using Compiler. Same idea, around 10% of the build time increase, pretty negligible. Exhibit C, a lot of lines of code. This will be a little bit restrictive. I cannot share everything, but I'll just show you the differences. As you can see, similar picture. If it's not media heavy, if it's media heavy, largest content paint will remain largely the same. But with Compiler, total blocking time went down, and in this case, I attribute that to the usage of micro frontends in this project. So don't take that. Take that with the grain of salt in this specific case. But what I want to go next is INP. Again, we're striking gold. We're seeing that just adopting Compiler without changing anything in the code base drastically improves our results in the interactiveness of our app. And even total blocking time went down, which is, again, in this case, this is a very large scale project, meaning that we do a lot more in the background of every button click and every event we call. So we are gaining much more in this case. And build time, as you can see, went down. And this is, I think, not a coincidence. When we have a larger code base, we have way more ways to give Compiler time to optimize our code base, remove redundancies. So I don't want to attribute it fully to Compiler, but I think it does its magic. Okay, and Exhibit D is just a quick overview that Next.js also is adopting Compiler, so you can do that, which can be a counterintuitive if you think about it, because in Next.js, our initial load is all we think about. We're trying to do hydration, we're trying to do server rendering, but still, I think they did a good job of not abandoning server-side rendering when they were developing Compiler. LCP, literally the same. It's a pretty small app. Total blocking time on load, also the same, even no delta. It was always at 30 milliseconds. But interactions are getting faster with Compiler, and total blocking time is getting faster with Compiler, which is pretty consistent with what we saw overall. So yeah, even in Next.js, you can start using Compiler today, which is pretty great. And build time also, a small reduction in build time. This one is negligible. I ran it on my local machine, so a change of 1 second can be attributed into CPU ones and zeros aligning better at those specific test cases, so I wouldn't look too much into it. Okay, and let's finish up with key takeaways. Compiler is not a part of React 19. So you should additionally install it as a dependency. It should be used with version 19, but it can be viable with version 18. As we saw, it gives you a huge boost if you use it on not even the latest version of React. As I already spoiled it by accident, Compiler is good enough for majority of the use cases, but keep in mind that it doesn't work with class components. So if your app is built on class components, you will not gain anything, well, almost anything from using the compiler. React Compiler will yield best results when you follow rules of React, meaning that you have to be diligent with your code. Compiler will back out of the components it cannot compile. So it will say, look, you wrote bad code, I cannot do anything with it. I'll give you a warning, do better next time. And I was concerned about build time difference. I thought that Compiler would take substantially longer to build projects, and as you saw, sometimes it even helps. So build time difference should not be a concern when thinking about Compiler. And yeah, in my honest opinion, Compiler is good enough for majority of use cases. Sorry, I should have changed that. And you can use both Compiler and manual memoization to get the absolute best performance out of your app. That is if you want to squeeze that 99th percentile of the performance, but you can just rip it right now and you will see amazing results. And public service announcement, compiler is not compatible with MobX. So if your project is using MobX, you're kind of missing out. And that's it for my talk. Lightning talk, pretty fast. Thank you for your time and attention, and let's get to Q&A time.
Thank you for your amazing talk. We do have a few questions for you, so let's get started. The first one is, what are the limitations or edge cases where React compiler doesn't help?
So one case was Exhibit A. I think React compiler might not be actively hurting, but will not help if your app is changing pages on every click. So that's one of the topics I wanted to cover when I'll get a chance, that I don't think React compiler will be a huge improvement for React native apps. Just because you'll be switching screens all the time, meaning that compiler will have to run its wheels. Sorry, not compiler, but React itself will have to memoize everything on the page again and again and again. So you're not gaining anything by that. So that would be my prime use case where React compiler is not shining and you don't need excessive memoization.
Yeah, that was very interesting. Another person is asking, how does the compiler affect bundle size and build times?
Okay, great question. Build times, as you saw, it's a bit of a flaky change. Sometimes it increases it by around 10%. Sometimes it gets down. I think for the bigger code bases, it will definitely be an improvement, just because, as I've said previously, compiler is more invasive in the way it tries to build your app, meaning that compiler will have more opportunities to optimize your bigger components, like those dreaded components that everyone has in their code base that are like 1,000 lines or more, which we all hate, which we all want to break down, but we just do not have time. This is where it will help. And for bundle size, I didn't see any substantial change. It's with compiler, again, as same as build times, it was hit or miss, sometimes 10% more, sometimes 10% less. So just don't sweat about it too much. It should be fine.
Perfect. Thank you so much for this. And we have one more question for you. How does React compiler performance compare between Webpack and Vite?
Oh, that's a good question. So I opted to test only Webpack for consistency of the results in my homebrew testing setup with a limited selection. I didn't see substantial difference. Vite, I always confuse the naming, is quicker on average than Webpack, but when switching from non-compiler to compiler, the difference is the same. So it will be just a bit of a fluke on both of the builders. So don't think that using Webpack you're losing out on performance with compiler. Webpack is just as good as a builder. Same goes for Vite. It's a good bundling tool, and you will not see any substantial improvements if pairing compiler with Vite specifically.
Perfect. Thank you so much for answering everything from our audience. I hope that you also had a nice time with us, and it was a pleasure having you here.
Okay, thank you. It's been a pleasure. Thank you, Elif.
Thank you.
Okay. Bye.